Okay, kids, it's concept number 2. If our concept number 1 was average rate of change, which gave us, in terms of a graphical model, gave us a function, and we came up with the secant between x and x plus h, and your secant line ran through there, and that slope, well, not the slope first, let's do the y values. That's f of x. That's f of x plus h. So the slope of the secant equaled delta y. Okay, here's the slope. Maybe I haven't made this clear. Okay, there's your rate triangle. So it's rise over run for slope, which is delta y over delta x, equals f of x plus h minus f of x over top of h. So that is your difference quotient. That's your slope of the secant. That was concept number 1. Let's now change it to, instead of average rate of change, let's change it to instantaneous rate of change. What we're going to do now is we're going to take this value of h and we're going to let it get smaller and smaller and smaller. And as that happens, this point is going to move closer and closer and closer to our other point. So it's moving closer and closer and closer. You'll see that the slope of the tangent is changing drastically, and it's getting closer and closer to a specific slope that just touches the curve that I would go so far as to call, if I have a red would be nice, right here. Not red enough, even better, right here, which we could say is the slope of the tangent at that point. Okay, so that is the tangent line at that point. The slope of the tangent will be calculated by doing a neat little thing, this concept called a limit. Okay, really neat little idea. And what we're going to do is we're going to apply the limit, a specific limit, as h gets 0 here. So the m of the tangent is now going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And this, ladies and gentlemen, is the slope of the tangent to this curve, any point, given an initial point and a little bit of distance away. That little bit of distance away is becoming 0, so it becomes the slope of the tangent at any value of x on f of x. I suppose I could word that better. It's the slope of the tangent to the function f of x at any value of x. That's probably worded much nicer. And that is the concept of the derivative. So you got a new name here. It's called the derivative. What is the derivative? The derivative is an operation. You take the derivative of another function. So you start with f of x and you take its derivative. What does the derivative function give you? The slope of the tangent anywhere on the original function f of x. That's what the derivative does. It gives you the slope of the tangent anywhere. It doesn't give you the tangent line. Pitaway, it's not the tangent line. James, it's not the tangent line. It is the slope of the tangent. Okay, so I think that's it for the concept. One other thing that I just may not have shown, but it's on the LMS and you can see it, that as this h value gets closer and closer to 0, this point is being pulled closer and closer and closer to this point, and you see all these secants are going closer and closer till they approximate the slope of the tangent. And there you go. That's concept number 2.